Well, how you doing, ACES people? So I'm Tim. I'm the ACES Fuel Injection R&D Manager. But one thing I want to do is take the opportunity to get the second gen ECU harness for like the Kill Shot 2. But a question I see a lot of is how do you utilize the relays that come in the kit versus the PDM? Well, relays, a lot of us out here, we know how to hook them up and all that, but we've painstakingly went ahead and put labels on the wires for you, and in this video, I want to show you how to hook a relay up and some good practices from crimping to soldering. And let's just move forward on this. And that way you guys can have an opportunity to do a clean install and not really leave anything left on the table when it comes into questions and concerns with your wiring harness itself. So let's get into that real quick. Welcome to the desk, everybody. So I've laid out a second gen harness for a Killshot 2 Pro. Now, I got my wire strippers, my crimpers, and this first demonstration here, you can see I got all my main wires just laid out here. No big deal. On this right here, we got the main power, we got the ignition wire, we got the MRD, main relay distribution, we got ground, and then we got our relay for our fuel pump. These two smaller black wires, MRD and relay fuel pump, these are the ground triggers from the ECU that'll turn the relays on. This main power is, well, what you think it is main power. It'll come from the main relay, and this ground right here, this will just go off to the battery. So let's look at our relays. We got, I'll move this out the way for you. The first one is the main relay. Now this has a few wiring tags on it right here. 12-volt battery, this goes directly to your battery. This main 12-volt out, this right here is what's going to be hooking into your main power right over here. So this main power right here, and these are going to hook together. And this right here is the trigger wire for it, which is main relay, which will connect to MRD. So that's that. We're going to connect this, but we're going to connect it in two different ways. And I'll show you guys why, because everybody has their own way that they like to do things. I come from a different background, so I have an opinion on it. Electricians, mechanics, everybody else in between, they all have different opinions on what a proper wiring method is. I'll show you two that is very common. But I'll explain a little bit of the, yes, it's acceptable, but also what can happen over time. So this relay right here, this is for the fuel pump. We're going to have the fuel pump wire. This triggers it. This will go out to the fuel pump, which will turn your fuel pump on. This is a pretty good wire gauge, so nothing too crazy there. I would match the same wire gauge. And then we have the two battery 12 volts. So this wire on this relay and this wire on this relay, you can tie them together and run that off to the battery and get good power. Or you can run separate wires off to the battery to ensure good clean power for each different circuit here. So with this, you want to use some decent crimpers. These ones right here are pretty good. Can't quite pronounce them, but they've been very loyal to me. We'll just go ahead and we'll just do one here. So when you're cutting your wire gauge right here, you want to make sure to select the right thing so you're not pulling extra copper off and damaging the actual wire itself. Every little scratch you make on the surface of this wire actually creates a problem because DC voltage likes to travel on the outside of the conductor itself. So you want to make sure this is nice and clean and not all frayed out, making it very difficult to actually connect anything. So traditionally, a lot of people use these insulated butt connectors. This is a real cheapy one. I got it, it's off the shelf at the local auto parts store. A lot of people use it. The caveat to that is just the right size for what we're doing here. Over time, where these things are not environmentally protected, they will tend to build some corrosion. Now, a good wire crimp, you want to give it a tug to make sure it's good to go. But a good wire crimp is at least the same quality or more superior than a soldered joint because of a few different reasons. If you crimp really good, which this type and this type of crimper doesn't allow it to actually fuse all the metal together, and allows for the conductor itself to actually be introduced into the environment and corrosion. You can buy these insulated butt connectors right here that has the heat shrink over top of it, and some of them you heat them up and it has a bit of solder built into them. And I've had some mixed reviews about those particular ones. Not a massive deal, but this right here, we got main power. This is going to the ECU. We know that the main power, main 12-volt out, is going to connect to that. So we found the appropriate hole here on our crimpers. Give it a little bit of push. You see I selected the wrong one. It pulled a few little pieces of wire off, which will be forever embedded in the carpet in my office. But that's okay. So the same thing, we're going to do this right here. I am a bit strange when it comes to these because I like my crimps to kind of be at the same angle. Good pair of crimpers. Nothing special with these. These are just your Harbor Freight ones, but they crimp pretty good. So we got a good solid connection. This is acceptable for most applications. If you use a non-insulated butt connectors, you'll need to use a little bit of heat shrink as well. So that way, before you make your final crimp, you get a little bit of heat shrink. Slide it over the wire, make the connection. That way it is a very, very, you can visually see it's a good connection. Slide the heat shrink over it, heat it up, shrink it. It's going to be good protection from environment. That's one of my favorite methods, especially when I'm doing a build and I don't want to have to go back behind myself to fix wiring a year and a half down the road because these terminals corroded from getting everything from hot, cold, vibration, then rainwater and dirt and all that. It'll just turn it green and make it eventually start to break. That's when you're tracking down, is my fuel pump really bad? Why do I have intermittent power? What's going on with this? So we've made this connection right here. We're actually going to wire these in a separate way. But let's get off here. We got 12-volt battery. This will go off to the battery itself. The next thing we need to wire is the main relay. This will also be on the other end, the MRD. So we're going to use the little one here, right there. A little bit. I might have done a bit too much. The normal standard on that is you want to do about 10 millimeters of insulation removal. That's appropriate for most connectors. And it also looks visually appealing as well. So you don't put your conductor into the connector itself and it's poking through so much that you can't put the other wire in. So the big risk factor on using these type of butt connectors is they only come in so many in a pack, and if you have a bad crimp and it pulls off, then you got one half that's really good and the other half that didn't work out so good, so you had to remove it. Sometimes if you can't get it to crimp the opposite direction, you got to cut the wire, strip it again, and it's a little bit shorter. You can only do that so much before you kind of run into a whole nother issue. So we're connected good there. This MRD, or this main relay, is going to go off over here to the MRD wire, which I'll get that right there. Main relay distribution, MRD. So let's go ahead and strip this back and connect it. Nice and smooth. You don't want to twist your wires. You want to kind of pull them straight in a way and keep that nice little concentric twist going. Otherwise, your wires kind of barber pole, as it goes in aviation terms, and that creates a whole nother issue with how the wires are laying over each other because of how DC voltage travels. So we got that in there, nice good crimp. Well, I got that off a little bit. That's going to bother me later, but that's okay. We're just doing this as a demonstration. I can fix this later. So we got a good solid crimp, nothing pulling out. Good to go. Same here. So we've got the power to the system, and we got the ability to trigger the main relay distribution circuit, which turns pretty much everything else on. This will go off to the battery right there. So that's done. Now let's look at the rest of it. We got the fuel pump trigger wire, and that's really it. So nothing too wild there. Just for thoroughness, I'll go ahead and hook this up the same method. I'll show you guys. The good thing about using relays, using the PDM is a good thing too. There we go. Nice bunched back together. The good thing about using the PDMs, it really cleans this up. You don't end up with electromechanical relays. It's a nice clean look. There's nothing wild about it. When you use relays, you can also mount them differently. Say you got a really confined space going on and there's not a lot of place to put this, so you can extend these wires out and mount them up underneath a fender somewhere, and just you know, put a nut and a bolt, weld a stud in, use a self tapper, whatever your method is. But a lot of folks I see out there, they're using a lot of zip ties and self tappers. I get it. I do the same thing, and well, I mean, this is what my job is. So, but in my case, it's a whole lot of really just we're putting something together good enough for now to do testing on, and then some of the other things we do is a lot more in-depth installations with proper techniques and everything. So I've ran test systems with patch cables on just for the sake of testing. Yeah, so nothing's pulling apart here. We're nice and solid connection. You got to make sure you want to test it, because later you're having a diagnostic nightmare trying to figure out what point this ain't triggering. Is it the system? Is it the firmware? Do we need to call customer service? No, just give that a little tug. Yep, it's in. So the next thing on our list is we have the 12-volt battery. This will go off to the battery. This wire right here, this orange wire, which is marked fuel pump, this will be the positive leg of your fuel pump. So the negative side will be grounded to something, frame rail or back to the battery or whatever your method is. This thing right here, about a 10 gauge wire, is going to run right off to your fuel pump. It's going to do a great job. The fuses that are in, like for instance, the fuel pump, let's get it out here. This is a 20. So that should be about right. Most fuel pumps run a solid 20. And then we got back here, we got a 30 on the main because it is a bit heavier wiring. It's a little bit more demanding than the fuel pump. This is all by itself. So now we got a trigger from the ECU for the fuel pump to turn on. This goes to the battery, that's the fuel pump. A trigger from the ECU for the main relay distribution to turn on. This is powering the system here, and this runs off to the battery. Perfect stuff, right? So anyways, with that, I hope that kind of clarifies some stuff. I know it's a little bit of a mess that I've done here, but all the way around the block, the only other thing you need to hook up is you take your ground right here off to the battery and hook up appropriately. You take your two positive wires, take those off to the battery, or splice them together and then run a larger main wire off to the battery so everything's supplied well. I like them to be separate personally, but on our diagram, we have them combined together. Then we got a clean ignition switch. Now, if you don't really have a good clean ignition switch signal, say you're getting it from a coil or something strange in your car or an alternator, you want to make sure to try to get another relay and incorporate that relay into your ignition switch wire. So when you turn that key on, even if it got dirty voltage, you got a stream of electricity coming from the battery itself through the relay, triggering this, and you use the dirty voltage to actually trigger the relay itself. So how that would look would be, because this is what's called a ground trigger setup, but in this combination, you'd have power coming in one direction, power coming out to this. This right here would go off to ground, and this would come from your triggered source on your car itself. So you see on this one, this is a ground trigger because both of these positive legs are tied together right here, because it's supplying power, it's sending power here, and it's only triggered by the ground side. So you can do a positive trigger where this is grounded and this is a trigger for it, or you can do a ground trigger where these are tied together appropriately, and this is what turns it on and off through a ground switch. So now I'll show you the other method of connecting some wires here. We'll pick like this one right here because it's a nice wire. But let me get that set up. I'll be right back with you. All right, so welcome back, everybody. I got my little helping hands out here. I actually stole this off my ring light. And so anyways, one of the methods that some people like to use is a bit of solder right here. Now there's a couple of methods that I find very interesting, but some people get them and they lace all the wires together and cram them end to end, which makes them kind of bulbous in the middle a bit. But also some people, like myself, I like to tin the wires with a bit of excess solder and then park them right next to each other. As long as it is a good, clean connection where the solder is not a cold weld or anything like that, and they hold nicely together, then you're good to go. That is also, weirdly enough, approved by aviation as well to do it just like that. So the type of solder we're using today, let me get my soldering iron out. I got one of those straight off of Amazon, very good. It's an actual station, so it has the heat gun like this right here. and it also has a soldering iron as well. It has selectable temperature. So because of the fact that we're using 7% copper, 99.3% tin, I believe the melting point of this stuff, and it's 0.8 millimeter, by the way, but the melting point of that is about 400-ish, 50 degrees Fahrenheit. You want to work with a good hot surface anyways, just to make sure everything's going very well. So I like to turn my soldering iron to about 750. That's a pretty good working range for what I do. It seems to work out. As long as you don't overheat your components, you should be pretty good. Now, this bit of a shrink we're going to use right here, this is just off the big spool I got. So it should be enough to accommodate that wire, especially the actual conductor in the middle times 2. So if we park them right next to each other, it should be good and still be pretty good grab on the wiring insulation itself. So we'll go ahead and slice that up. Let me get my flush cuts. And we are going to go about there with it. That's maybe a little bit excessive for some people. I like a lot of heat shrink on it. So either way, we're just go ahead and send that down the pipe there. No big deal. Now this right here, I'm using lead-free flux it's actually a tinning flux, but this also, it helps stop your solder from oxidizing when you're trying to make that initial give it a go and put the solder on the conductor itself. So we'll go ahead and clamp this in, and we'll go ahead and clamp that in. Not a big deal. Sorry about all the noise, but it's just part of the process. This right here, you don't want to necessarily feed the copper into the actual soldering iron like this. See, it's kind of has a difficulty because you can overheat it and it becomes difficult. But you do want to get the actual conductor hot and start kind of feeding it into the wire itself. See, it's nice and tinned. There we go. Nice and beautiful. We'll do both of these, and we notice that one wire is a little bit bigger than the other. That's not a massive deal. So yeah, we're doing really good. One of the risk factors on this is you actually end up, I forgot the exact technical term for it, but it's when your solder is actually continuing on down through the insulation and it gets very firm back here. The issue with using solder on an automotive application is vibration. Heat and vibration over time actually cause these solder joints to kind of break themselves. So where we have solder on this, and it's looking pretty good, we need to find, with my little helping hands here, this is way harder to do up underneath the dash with everything in the way. These things, they don't hold much, but yeah, you get them oriented just right, you can finally get them to go. There we go. That ought to work. I'll go ahead and tin my soldering iron. We're going to go in here. We're going to heat this up. Might have to feed a little bit. Kind of think of it like TIG welding. Get a nice puddle. Chase the keyhole, right? Chase the keyhole. There we go. Nice and warm. See how they're both doing their job now. So we're going to let that cool. Not too terribly hot. I can feel a little bit of warmth in my fingernails, on my fingertips, but nothing crazy. And now with this, we go ahead and undo that. You can see they're side by side, but they're welded together very nicely. So they're not really going to break apart. We didn't interlace them. It doesn't look like there's any kind of oxidation going on. There's no voids or gaps or anything. So wait till that's nice and touchable, because one rookie mistake is you get this still blazing hot, and then you try to get your insulation up over top of it. It starts shrinking on the way, and then it is absolutely stuck, and there's not a lot you can do about it. So you wait till it's pretty nice and cool, slide your insulation on, then you get your heat gun, which mine is cooking at about 900 degrees right now, but that's the nature of a heat gun, right? Right there. Just a nice heat shrink. Nothing too wild. We're not melting anything. We're not desoldering it while we're trying to shrink it. And that should be it. If you're going to go this method, it's pretty good. You can do this style right here. You can lace them together. You can twist them together if you want to. I like this right here because it's very quick and it's maintenance friendly. So now the wire has really nice bend, but you see it's not going to bend where the solder is, and that's where that heat and vibration comes into later. Of it's going to be harder here, so over time it will fatigue and then start to crack, and you have a very odd cold solder joint going on, and you're trying to diagnose something. So you're trying to probe this side of the wire and that side of the wire, and you realize it's just your solder joint you did 2 or 3 years ago in your race car. So if you're going to do that, that works out pretty good too. I'd recommend using uninsulated butt connector and heat shrink. Get a really good crimp on there with some proper pliers or proper crimpers, and just do a heat shrink over top of it. You're really going to thank yourself later. So I hope that helps.